Hi, I'm Paul Battaglia, and this is section 4.5. Students enter section 4.5 with a good knowledge of some basic integration rules, but now it's time to get a little bit more complex because certainly not everything they see from here on in will be that basic. So to that end, our essential question is this: how do we integrate using substitution? Now, the easiest answer to give students right away is you need to be ready to practice, practice, practice. It's very much like when they first encountered the product rule, or the quotient rule, or the chain rule. Those things were not things that they could master after 5 or 6 examples, or even 5 or 6 homework exercises. So similarly, they need to do that with integration by substitution. To help them out in the class, what I'd like to do is I'd like to give them 3 options of things to look for as candidates for substitution. The first one would be, look in the integrand and see if you can find a differentiable power function and its derivative, the product of those two. Secondly, if you're faced with an exponential function, do you see the exponent as a good candidate for substitution? And finally, third, if you're facing a trigonometric function, the angle might be a good place to start. Let's look a little bit more at example 3. Example 3 is a great example for showing why we need to do a good one-to-one substitution. You'll see us use the variable u many times, and so oftentimes I'll call it in class u substitution. In example 3, we're going to say let u equal x squared plus 1. Now, du would equal 2x dx. And students can see the x dx in the original integrand, but the question becomes, well, where did this 2 come from, and how do I make an equivalent adjustment for that? And what we want to stress for students here is you need to go ahead and solve for dx. And in this particular example, we're actually going to solve for x dx. When we do that, x dx equals du divided by 2. So what we'll need to do is we'll need to put a 1/2 on the outside to counterbalance what we just saw. Now, that being said, here's a common mistake students often make. They see the x dx and they say, well, can't I just cancel that out by putting a 1 over x? I mean, if you were going to put a 1 over 2 out there, why can't I do that with variables? And the answer is, well, you need to have that equivalent substitution, and there's no way that those things would match up to the original integrand. While we're talking about mistakes, let's look at a couple of the other examples. Look closely at example 5. Example 5 is a great example because it talks about the change of variable process. In that particular example, we'll make u equal 2x minus 1. Now, if we solve for x, because we have to kind of circumnavigate the substitution process, x will wind up equaling u plus 1 divided by 2. Now students think, okay, I'm ready to roll. Let's just kind of go on through our way. But what they've forgotten the entire time is we have to make that equivalent substitution for dx. So again, they're going to have to solve correctly and make sure everything matches up with the original integrand. Now finally, examples 8 and 9 are great to talk about because they're using u substitution with definite integrals. So there's an emphasis now on the limits of integration. So here are some things that students might miss. They've made their u substitution correctly and they're ready to integrate. And in fact, they do so. But they still use the original limits that they were given. And this would be incorrect. What students have to do is they have to plug each of those limits back into the expression they used for u and get new limits. Every once in a while, one or both of the limits will actually remain the same, but I would caution them that that would be merely a coincidence. That doesn't always happen. Furthermore, in example 9, they have the idea that when we change those limits, if we do it successfully, the lower limit actually winds up being a higher value than the upper limit. We don't want to change the order. We want to keep the order. It's fine as it is. Go through the regular process. Everything will be fine. Now, once again, I'd like to reiterate what I said before, and that is students need to practice. They need to make sure that they master this so that as we go forward, they'll feel much more comfortable when they're confronted with other types of integration. This is certainly a large part of the strategy they need to master. Yes, we'll look at how to integrate certain rational functions or even some inverse trigonometric functions in the next few sections. But for right now, you really can't move on until you feel that your class is really ready with integration by substitution. One more point. My students will sometimes ask me, you know, do I have to change to u? Do I have to change the bounds? Can I really just change it back? I just feel more comfortable. My answer is, of course you could change it back. However, as we've said multiple times throughout the course, you have to be ready to recognize alternate forms. And this is certainly an alternate form of an integral that you might be faced with either on my assessment or on the AP exam. I hope these tips help. I'm sure you'll find much success in section 4.5.